Welcome to AppSex online sport program. I am Anam Irfan from Hamza Army Public School and College. This is physics lesson for class 9th. In lecture number 1, we will study unit number 6, work and energy. Objective. In this lecture, you will be able to define work and its SI unit. Calculate work done using equation work is equal to force multiplied by distance moved in the direction of force. Define energy, kinetic energy, potential energy and state its unit. Our first topic is work. Generally, work refers to perform some task or job. In science, work has precise meaning. For example, a man carrying a load is doing work, but he is not doing work if he is not moving while keeping the load on his head. Scientifically, work is done only when an effort or force moves an object. When work is done, energy is used. Thus, work and energy are related to each other. The concept of energy is important in physics. It helps us to identify the changes that occur when work is done. The unit deals with concept of work, power and energy. So work. In physics, work is said to be done when a force acts on a body and moves it in the direction of the force. The question arises, how much work is done? As naturally, greater is the force acting on a body and the longer is the distance moved by it. If we pulling a cart, then when we apply greater force, then the cart will move in the longer distance. But if the force is less, then shorter is the distance moved by the cart. So smaller will be the work done. Mathematically, work is the product of force and displacement in the direction of force. Thus, work done is equal to force multiplied by displacement. It means work depends upon the force and the displacement in the direction of the force. The larger is the force, the larger is the work. Or we can say that longer is the distance moved by it and the larger would be the work done. And if smaller is the force acting on a body, then smaller is the distance moved by the body and smaller will be the work done. So, work done depends upon force and displacement. They are directly related to each other. When force is greater, work done is greater. When displacement is greater, work done is greater. So, they are directly proportional to each other. In figure, we are discussing about work done in displacing a body in the direction of force. The force is in this direction. It means we are applying a force on the block from this direction and the block move through the distance s in this direction, in the direction of force. Hence, we can say that work is done on the object because it displaces the body in the direction of force. Next is sometimes force and displacement do not have the same direction. Now we will study unit number 6 and our topic is unit of work. SI unit of work is joule. It is defined as the amount of work is 1 joule when a force of 1 Newton displaces a body through 1 meter in the direction of force. So we are discussing unit of work. We know that the work is measured in joule. And what is the joule? It is the product of Newton and meter. Why? Because force always measured in Newton and the distance is always measured in meter. As work is the product of force and the displacement, so the work done will be the product of Newton and meter, the unit of force and the unit of displacement. Joule is the smallest unit of work. Its bigger unit are 1 kilojoule, it means 1000 joule, or we can say that 10 raised to power 3 joule. 1 megajoule, or we can say that 1000 times of 1 kilojoule, or we can conclude it as 10 raised to power 6 joule. Sometimes force and displacement do not have the same direction. Then what will be the value of work done? If force, we know that work can be done when the body displaces in the direction of force. But if force and displacement do not have same direction, then how much work is done? So here is the case. Here is the force making an angle theta with the surface on which body is moved. We are applying force in this direction, which is making an angle theta with the surface on which body is moved. So when we are applying force in the direction of theta, then we resolve the force into its perpendicular component, or we can say that into the x component and the y component. Here is the x component, which is also known as horizontal component. Here is the y component, which is also known as vertical component. By resolving the force, we are considering that the block is moving from this direction to this direction. It means which component of force is providing the force and it moves through the displacement S. So the body is not moving in the Fy component. It means body is not moving in the vertical direction. It is moving in the horizontal direction. It means x component of force. Due to x component of force, the body moves. And it causes the body to move on the surface, not the y component. Fx causes the body to move on the surface. That's why the body is moving along the x component. So we can say that work done can be done due to the x component of force because the body is moving in the horizontal direction. So when we resolve the force into its perpendicular component, we know that there are two components, Fx and Fy, which is x component of force and y component of force. The formula for the x component of force is F cos theta, and the formula for the y component of force is F sin theta. In case when force and displacement are not parallel, because force and displacement are not in the same direction, then only x component of force parallel to the surface causes the body to move on the surface, not the y component. Hence, the formula become work done is equal to Fx into S. By putting the value of x component of force, we get the formula of work done as work done is equal to force into cos theta into S as it is. S denotes the displacement of the body. And the formula becomes Fs cos theta. Now, how can we define the work? Work is done when a force acting on a body displaces it in the direction of force. This formula shows that work done depends upon force, displacement, and theta. It means angle between the force and the displacement. If force change, the work done change. If the displacement changes, the work done will also changes. And if theta, which is the angle between force and displacement, changes, then the amount of work done will also change. So, if there is the larger force, work done will be larger. And if there is smaller force, the work done will be smaller. If the body covers the greater distance, then the work done will also be greater. If the body covers smaller displacement, then work done will also be smaller. And what about the theta angle? If force and displacement are parallel to each other, it means they both have same direction. If they both have same direction, then the angle between them will be 0. If the angle between them is 0, it means force and displacement are parallel to each other, then work done will be maximum, which is Fs. Second case, if the angle between them is 90 degree, it means force and displacement are perpendicular to each other. They are making angle 90 degree with each other. Then the work done will be 0, because we know that cos 90 degree is 0, and by the product with the force and displacement, the work done will be 0. What third case? What happens when force and displacement are anti-parallel to each other? When the angle between force and displacement are 180 degree, it means they both are anti-parallel to each other, then work done will be negative, because we know that cos 180 degree is -1, and the work done will be minus Fs. So, by changing the angle between the force and displacement, work done will also be changed. So, work is a scalar quantity, and scalar quantity is the quantity which is described by its magnitude only. It depends on the force acting on the body, displacement of the body, and the angle between them. Our next topic is energy. The energy is an important and fundamental concept in science. It links almost all the natural phenomena. When we say that the body has energy, we mean that it has ability to do work. Why we need food? We need food for energy. And why we need energy? So that we are able to work. So we can say that if a body has energy, it means that it has ability to do work. Water running down the stream has the ability to do work, so it possesses energy. The energy of running water can be used to run water mills or water turbines. Energy exists in various forms. such as mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy. How can we get these energy? First is mechanical energy. Mechanical energy, the moving object possesses mechanical energy, like moving fan possesses mechanical energy. Heat energy, the major source of heat energy is sun. Light energy, we can also get light energy from sun, from bulbs. Sound energy, we can get the sound energy from vibrating bodies. Electrical energy, we can get electrical energy from electric power stations such as hydropower stations, nuclear power stations, etc. Chemical energy, we get chemical energy from the food. And nuclear energy, we can get nuclear energy from the nuclear power plants, where fission and fusion can cause the nuclear energy. Energy can be transformed from one form to another. So how can we define energy? A body possesses energy if it is capable to do work. First is mechanical energy. Mechanical energy, the moving object possessed mechanical energy. So mechanical energy possessed by a body is of two types. First is kinetic energy and the second is potential energy. Kinetic energy, the energy possessed by a body due to its motion, is called its kinetic energy. Potential energy, the energy possessed by a body due to its position, is known as potential energy. Critical thinking. When does a force do maximum work? We know that work done depends upon the force, displacement, and the angle between the force and displacement. Its formula is work done is equal to Fs cos theta. When the value of cos theta maximum, then work done will be maximum. It means when the angle between force and displacement is 0 degree, it means force and displacement are parallel to each other, then the value of cos theta will be maximum and the work done will also be maximum. So we can say that a force can do maximum work when the force and displacement are parallel to each other. It means they both have 0 degree angle between them, then the work done will be maximum. When does a force do minimum work? You have to answer about when does a force do minimum work. Third is, why do we need energy? Why do we need energy? We need energy for our various purposes. If a body has energy, it means that it has ability to do work. So for ability to do work, we need energy, and we get energy from our food, due to which we are able to do our daily tasks. Next is assignment. Do mini exercise given on page number 120. Write answers of the question 6.2, 6.3, 6.4 and 6.5. Learn all the definitions given in this lecture. You have to read the book so that you can get all the concepts from the book. I hope you all understand the lecture. If you have any question, you can ask Thank you so much. Allah Hafiz.